that's in place of his special diode. Here we have a bank of capacitors. They are 25 volt, 330 UF capacitors, and there's 4, split into 2. I've got 2 wired in parallel, that's connected across the voltage supply, and I've got 2 in parallel connected across the EMF output, and across the other side of the diode. Basically, in replace of the 440 UF capacitor. Yes, I'm only using 25 volt capacitors. Simple reason being that a 400 volt capacitor just is not necessary, and I'm going to prove it. As you can see, I've taken off the LEDs there that were keeping the voltage down, and you can already see 10.3. I've stopped the wheel so it doesn't overload the capacitors. Right, flick it up and you can see up goes the voltage. So it's 20, 23, 24, 25, 26. Oh, that's already over the rating of the capacitors. Oh well, I'll add it up to 30. I'll stop it when it gets to 30. Now that's just so you can see how much voltage is actually coming out. I'm struggling a bit now. I haven't tuned this properly. Right, anyway, 30 volts. Right, so I'm going to stop it. Slowly drops back down again. Okay, so take this out. 2 banana plugs, and there we go. Oh. Right, that should have gotten rid of. There we go. 0.3 volts, 0.4. Oh well. Right, I'm going to take something. Where is it? There. Little lead with crop clips on. Right. From the positive, there on the multimeter. Right. Now, I'm going to connect this directly to the input, which is this little junction block here that you can see at the top. Right. That'll do fine. Okay. Watch this. Spin it up. I'll let it reach probably about 25 volts. 23. 24. 25. Connected. Little spark, as you'd expect. And there we go. Right, let's change this. Move the range slightly. Right. Remember what I was saying earlier about on the SK3606 the forward voltage drop was 1.47, right? On mine it's 0.6. Right? Guess what the reading is on the multimeter? 0.6. Well, 0.63, 0.64. Okay. So that means that those sets of diodes are shorting out. Those sets of capacitors are shorting out through that special diode. The reason that he has such a large capacity diode, in my opinion, is so that when he discharges the capacitor into his primary battery, thus shorting out the capacitor, right, there may be 15 volts shorting out, going from positive to negative. Right, so in my view, basically it's complete and utter rubbish. it shorts out through the diode. Now, on his video, he does actually show the battery voltage, and the battery voltage rises. Right. That's not hard to do. Here's what happens. While he's charging his capacitor at the start and waiting for the neon to come on, right, the Brazilian circuit itself isn't really under load. Right, the fan's excuse me, perfectly allowed to spin as fast as it can. Right. As soon as he connects the feedback to the positive of the battery, the fan runs slow. Right. This is due to lens effect. What's happening is all the back EMF that's coming out of his coils being shorted out and creating a lens effect inside the fan, thus slowing the fan down. Now, this has a knock-on effect. Because the fan's now slowed down, it's drawing less current off the primary battery, which means the primary battery voltage is going to go up. Hence why in the video he shows it going up. Ergo, end of story. It's a fake. Thanks guys. Hope this was informative. And I'm pretty sure that Fusion Chip is going to have a few words to say. Go right ahead. Talk to you later.